in example 1, we looked at how to solve a logarithmic equation that can be written as a logarithm equal to a number. So now in example 2, we're going to explore the other type of logarithmic equation where you have log base a of something is equal to log base a of something else. Okay, so this is the bottom or of page 2 of the 6.6 notes. There are steps written down for solving an equation of this form. Okay, again, I am not going to read through these. I think it's very helpful to just work the problems in example 2. But again, these rules are here if you need to glance back at them. Okay, so again, in example 2, we're going to work with an equation that looks like this, where you have a logarithm equal to a logarithm, and they have the logarithms have the same base. Again, the equation may not come exactly like this. For example, you might have 2 logarithms on one side and then 1 logarithm on the other side of the equation. And so you may have to condense the 2 logarithms on the left side of the equation to make it look like a logarithm equal to a logarithm. Okay, so again, we're about to explore in example 2 equations that can be made to look like this. Okay, logarithm equal to a logarithm. The logarithms are the same base. Okay, so let's take a look at them. Okay, so here comes example 2. Okay, let's get the directions here. Hang on. All right, so it says solve each logarithmic equation, express irrational solutions in exact form, no decimals, and as a decimal rounded to 3 decimal places. Okay, in part A, our equation is log base 2 of 5 plus log base 2 of x minus 3 is equal to log base 2 of x plus 5. Okay, first of all, the good news is they are all log base 2. Okay. The other thing to think about, okay, so this is the mindset you're going to kind of want to go into solving logarithmic equations with, okay? You're going to ask yourself, can I make this guy look like either a logarithm equal to a number, or is it going to be easier for me to make this guy look like a logarithm equal to a logarithm, okay? Notice there are logarithms on both sides of the equation, okay? And there is no single number. You don't have like a single number hanging out there, okay? Like for example, when we did the problems, like let me go back to example 1, when we looked at example C and D, okay? You had a number hanging out somewhere, okay? That's not what you have here, okay? Every term contains a logarithm, okay? So in that situation, it is going to be easier. The only thing that's going to be possible is to turn this equation into a logarithm equal to a logarithm, okay? So what we're going to do here is we're going to combine the guys on the left side into one logarithm of base 2, and then we'll have one log base 2 equal to another log base 2, and then I'll show you where to go from there, okay? All right, so on the left side, we are going to condense these, and we can do that because they're both base 2. We are adding 2 logarithms, so if we refer back to section 6.5, if we are adding 2 logarithms, addition will turn into multiplication. So we're going to go this direction to condense them. So let's apply that rule to the left side. We are going to get log base 2 of, you're going to multiply your quantities together. Okay, so I've got to multiply the things that I'm taking the logarithms of. So this is going to be 5 times the quantity x minus 3. Okay, you're going to have to distribute the 5 through the x minus 3. So make sure you use parentheses wisely there. Okay, so that's how you combine these into one logarithm. Okay, you're going to leave this other logarithm on the other side. Okay, so leave it like that. Okay, so let's go ahead and multiply out what we have in parentheses. Okay, we're going to get log base 2, distribute the 5, of 5x minus 15, okay, is equal to log base 2 of x plus 5, okay? And now you have a logarithm equal to a logarithm, and they're both base 2, okay? So this is actually really easy to solve, okay? Use common sense here, okay? On both sides, okay, these are equal, okay? Both sides are equal. On both sides, you have a log base 2, okay? The only way this can be a true statement for the log on the left to equal the log on the right is if the somethings are equal, okay? So we're going to set 5x minus 15 equal to x plus 5. And we're going to solve that, and we're going to be done, okay? If you have two logarithms of the same base equal to each other, the only way that can be possible is if the stuff you're taking the logarithm of is equal to each other. That's it, okay? So solve this for x. This is a linear equation. The highest power of x is 1, so just isolate the x. So I'm going to move all the x's to one side, so I'm going to move this x over. I'm going to get 4x minus 15 is equal to 5. Add the 15. I'm going to get 4x is equal to 20. Divide by 4. X is 5. That's my solution. Okay? Let's go back to the original equation and make sure it is legal to plug in a 5. Okay? Here there's no x, so we're okay. Here, this would be log base 2 of 5 minus 3. That would be log base 2 of 2. That's okay. You're taking the logarithm of a positive number. Over here, if you plugged in x is 5, it would be log base 2 of 5 plus 5. That's log base 2 of 10. You're good, okay? You're still taking the logarithm of something positive, okay? So 5 is your only solution. All right, in part B, okay? Again, a very similar situation, okay? We have 3 logarithms in total, 2 on the left and 1 on the right, okay? Every term has a logarithm. You do not see a single number floating around without a logarithm. So it's going to be in your best interest to turn this into a logarithm equal to a logarithm. Okay, so go ahead and combine the 2 on the left side of the equal sign. Okay, we just saw in part A that if you're adding 2 logarithms, that you're going to combine these by turning the addition into multiplication. Okay, so we're going to retain natural log because everything is a natural log in this problem. Okay, so you are going to turn addition into multiplication. So you're going to multiply the stuff that you're taking the logs of. Okay, so this is going to be the package deal x minus 1 times x. You need parentheses there because you're going to have to distribute the x. Okay, is equal to the natural log of 2x. Okay, so let's go ahead and distribute inside the parentheses. You're going to get the natural log of, if you distribute the x, this is going to be x squared minus x equal to natural log of 2x. Okay, all right, so at this step, okay, you've got a natural log equal to a natural log. Okay, so you've got the same logarithm on both sides. Okay, natural log of something equal to natural log of something else. The only way this can be a true statement is if this quantity is equal to this quantity. Okay, all right, so we're going to set the insides equal to each other. So you're going to get x squared minus x is equal to 2x. Okay, let me draw my little line. All right, so now we need to solve this equation. Okay, the logarithms are gone. Okay, look at what we're left with. The highest power of x is 2, so this is quadratic. Okay, we need to put everything on one side and make one side 0. So I'm going to move this 2x over. I'm going to get x squared minus 3x is equal to 0. Okay, we can factor the non-zero side here, or you can use the quadratic formula. If you went the quadratic formula route, a would be 1, b would be -3, and c would be 0. Okay, if we factor this, we look at what's in common. You can take out an x from both pieces. That's going to leave us with x minus 3. Okay, because again, if you distribute it back out, you're going to get x squared minus 3x. All right, so over here, we need to set each factor equal to 0. Remember, factors are the things that you're multiplying together. Okay, so you have two factors. You have x. You need to set that equal to 0 and solve. So that's one solution. And then you need to take the other factor, set it to 0, and solve. So just add 3 to both sides. You're going to get x equals 3. Okay, so those are your two potential solutions. Okay, we need to go check them in the original problem, okay, to make sure that plugging them in does not cause us to take the logarithm of 0 or of a negative number. So let's check out 0 first. Okay, so if you go and plug in 0 to the original equation, okay, I'll write it over here. Okay, so if I'm checking this out, okay, if I check out x equals 0, okay, if I plug it into this very first term here, I'm going to get the natural log of 0 minus 1, which is the natural log of negative 1. That's bad. I cannot take the natural log of a negative number. Okay, so automatically I've got to throw out 0. Okay, it doesn't work. Can't be a solution. Okay, all right, let's check the 3. Okay, if I plug in 3, I'm going to get the natural log of 3 minus 1. That's the natural log of 2. That's good. It's going to be a decimal. Doesn't matter. I'm taking the logarithm of something positive. Plug it in here. Natural log of 3. That's okay. And then here, natural log of 2 times 3. That's going to be the natural log of 6. That is okay. Okay. So in this case, for this example, 3 is going to be your only solution.